so this is really your definition of an inverse. A lot of times whenever we talk about inverses, from what you've learned, you probably more than likely think about it's like switching the x and y's in the equation, or maybe possibly what the graph looks like. It's going to be reflected over that line y equals x. This is usually not what we spend most of our time on, but inverses really are the function that undoes another function, right? So, like, for example, if I give you a really simple function, f of x equals x plus 5, right? What's the inverse of adding 5? Subtracting 5, right? It'd be x minus 5. So those two would be inverses of each other. We know this because they're really simple, right? What is done in the first function is reversed by the second function. It's your undoing function. So for all inverses, if you do f of g of x, so you do f of g, you should just get x back because one function undoes the other, right? Same thing if you do g of f of x, you should still just get an x because one function undoes the other and you just get what you put in the first place, right? So you may see this, mostly we need this to develop the definition of the derivative of an inverse. Should I cut this? My husband put cameras up at our house, but he's home today and he's still got it on, and I think he's taking the dog out. I got to cut those notifications off. Here we need to do f of g of x to see what we get for this. So if I do f of g of x, then that would be taking g, the cube root stuff here, and plugging it in right here. So I would have 2 times the cube root of x plus 1 over 2 to the third minus 1. Now, when I do this, I'm going to have several things cancel out. What's the first thing that's going to cancel? The cube root and the cube. Those cancel out. So I'm going to have 2 times x plus 1 over 2 minus 1. What's the next thing that would cancel out? The 2's would be gone. I'd have x plus 1 minus 1, and now the 1's would cancel out. I would just get an x. So this should confirm partially that we're probably dealing with inverses here. Now, I, as a teacher, have never came across a problem where f of g of x equals x, but g of f of x does not equal x. However, the definition says you do have to check both ways. Maybe there are some problems where this happens. Like I said, I've not came across one. So if we're going to do this other direction, we got to do g of f of x. So this time we're plugging f into g. So we would have the cube root of 2x to the third minus 1 plus 1 over 2. What is the first thing that cancels here? It's the 1's. There are parentheses here, but there's nothing in front of it, so you basically just drop those parentheses. So that minus 1 plus 1 cancels first. You can't cancel the 2's because you still have plus or minus stuff there. But now, once you got rid of that stuff, you just got 2x cubed over 2. Now what can happen? 2's can go, right? And now you have the cube root of x to the third, which is just x. So this would verify that that two functions are inverses here. Okay, questions on that? I think that's really all we need to do with this, because I'm not going to ask you to do this necessarily. We just need this idea to build our definition of the derivative of an inverse. So we're going to stop at that for this. I think I have one more, but we're not going to mess with that right now. So let's go to today's notes. All right, so we're going to begin by doing a little bit of practice with what we already were talking about yesterday. Okay, so well, actually no, okay. So this notation is complicated. Let's talk about what this question right here is asking us to find. The slope of the inverse function at 8. Right? This is f inverse prime. Right? So this is the derivative of f inverse at 8. Alright, so the first thing I would like to do is kind of get a graph of what we're looking at for f and f inverse. So f is x to the third. Alright, so let's just plug in some numbers and get us a little graph here. So like if I plug in -2, what is -2 to the third power? -8. So -2, -8 would be right here. If I plug in -1, I'll get -1. If I plug in 0, I'll get 0. If I plug in 1, I will get 1. If I plug in 2, I will get 8. He has returned.
He likes red.
Uh-oh. Oh, man. All right. Now, we could go on and do like 3, but that'd be 27, and that would not fit on our graph, so I'm going to leave that off. So, if I want a graph of f inverse, right? If I want a graph of f inverse, let me use green for that. What could I do with my points that I already have? Just flip them, right? Like flip these lists right here. So I'd have -8, -2, -1, -1, 0, 0, and 1, 1 all stay in the same spot. I would have 8, 2. I'm going to put 27, 3 on there, but it doesn't fit on my graph. So if I graph these points, I've got -8, -2. These 3 points right here stay the same because they were already, on that line y equals x, and 8, 2 goes here. And so this graph is going to look like this. Okay, now, this question did not ask me for the derivative. It did not ask for f prime of 8. It asked for f prime of the inverse at 8, right? So, if really the only way we know how to do this right now is to find the inverse, right? There's a reason I've done this graph here. I'm going to show you guys something here in a second. You wouldn't necessarily have to do the inverse to be able to do this problem, but or the graph to do this problem. So if I want to find f inverse, then I would need to switch my x and y's, right? So I'd have x equals y to the third. And what would I do to solve that for my new y? Cube root. And so f inverse of x is the cube root of x. And if I want to take the derivative of that, it will be easier to do if I write that as x to the 1/3. Okay? So if I take the derivative of the inverse, notation is a little tricky on this. It's f inverse. You're going to put brackets around it and do a prime of x. And so to take the derivative of x to the 1/3, I have 1/3 x to the negative 2/3, which will be a little easier to deal with if we send that back down to the bottom, and probably even better if we make it back to a root. So 1/3 times the cube root of x squared. Okay, so we are almost to the answer on this problem. What do I need to do at this point to find f inverse prime of 8? Just plug in 8, right? So f inverse prime of 8 would be 1/3 times the cube root of 8 squared. And remember, with that cube root of 8 squared, we can think of that, like you can do 8 squared 64 and find the cube root of that. That works fine. But sometimes when you do it that way, the numbers get too big. The other way you can think about this, it is also equivalent to say the cube root of 8 squared. And what is the cube root of 8? 2. 2 squared is 4. So we've got... yes. So 1/3 times 4, and we get 1/12. And if we look at what we're finding here, that is the slope of the tangent line at this point. And gosh, 12th, that would be like a tangent line that looks something like this, maybe. We're finding the slope of that tangent line. That looks reasonable. It should be a pretty flat slope on that. Now, this process here can be done with any problem where you know how to find the inverse and you know how to take the derivative of that inverse. So like on this, it was a very simple inverse, right? The inverse of a cube is just the cube root. It was a very simple inverse. It was not a terribly difficult derivative, right? So we could just do that for this problem. The whole graphing is because I want to show you something here in a second. So you didn't have to graph this to do this problem. However, sometimes the inverse is not very easy to find. And sometimes once you do find the inverse, the derivative is very difficult to find. Or there can be cases where we don't know how to find the inverse at all. So I want to point out something on our graph here that is going to always be the case. So we were looking at this point on our inverse, 8, 2, right? What is the point that corresponds with that point on the original function? 2, 8, right? That was our original point on the original function. So the point 2, 8 was right here. Okay, now let's find f prime of 8. So if we find f prime of 8, f prime of x is 3x squared. F prime of 8. Oh, I'm sorry, not f prime of 8. We don't want f prime of 8. We want f prime of 2. Because 2 is the x value on that corresponding point. So we want 2, and then we got 3 times 2 squared. That's going to give you 12. Right? So the slope of this tangent line right here is 12, whereas on your corresponding point, your slope was 1 over 12. Is this a coincidence? I think not. Okay? So, this work, if there's going to be a rule that we know, it's very easy to find the derivative of x to the third, right? At this point, we should all feel that it is very easy to find the derivative of x to the third. If we don't, you need to be in smart breakfast. So, here, this should be very easy. So there is going to be a rule that we are going to develop here in a second, where we don't actually have to find the inverse of a function to be able to find the derivative of the inverse. And that will make it much quicker to find the derivative. So, did I really wait till that long to do that? I guess so. Do I want to do all this is the question. No. All right, let's look at this one on Desmos so we can do it quicker. I'm going to do this one. I might skip the next one. All right. All right. All right. So if I've got h of x equals x to the second plus 1. There's this graph, right? But we are going to restrict this to x is greater than or equal to 0. So we only want to look at this part of it. All right, so Desmos is so wonderful, although they don't let us use it, because I can switch my x and y's on Desmos. X equals y to the second plus 1 right here. And then let's make this where y is greater than or equal to 0. So although I didn't actually go through the work to find it, there's our inverse right there, because you can just switch x and y's and you don't even have to solve for that. So the red graph is the original, the blue graph is the derivative. So they are asking us for the derivative at 5. Okay, so right here at 5, we've got the 0.52 on our inverse, right? What would be the corresponding point on the original? 2, 5, right? Okay, so 2, 5.